Welcome. Let's solve Leetcode 2762 continuous subarrays. You are given a zero-indexed integer array nums. A subarray of nums is called continuous if all of the elements within the range have an absolute value difference of 2. Return the total number of continuous subarrays. A subarray is contiguous, non-empty sequence of elements within an array. Okay, that's a lot. So let's go over the example to maybe clarify their explanation or description of the problem. So what they're asking is how many continuous subarrays. Continuous means they're connected. There's no gaps, and they also include a single element array. So they consider each element individually as being able to contribute to the total. So there's 4 elements, so that was 4 values that we can add to the total. In addition, if we pairwise include them, so 5 4 4 4 2 and 2 4, those are also contiguous, and their absolute difference is less than or equal to 2. And if we consider 4 2 and 4, this is a continuous subarray, and the absolute value for every element within the subarray is less than or equal to 2. So adding each of these results up, 4 plus 3 plus 1 gives us 8. So this array has 4 continuous subarrays where their definition of continuous includes contiguous as well as this absolute difference pairwise requirement here. Okay, and this is pretty much the same thing. So let's go over the algorithm we'll be using to solve this. It's kind of I would describe it as a cached sliding window, something like that. So let's go over this here. Let me actually, let's copy this down. Okay. Now I'm gonna kind of jump ahead here and somewhat to the middle of the explanation of the algorithm, because I think this part is the most important part, and this is what I would call the focus of the understanding of the algorithm that's required. So let me just jump to this really quickly. Let me just try something like, suppose we're dealing with we're here, and maybe we'll call it 7 maybe, and 4, 2, and we'll call this 3. Okay, so what we'll be doing is we'll be using a dictionary to store. We will use a dictionary to store a value and its latest index. So what I mean by latest index is something like this. Suppose we have 4, 7, 4. So just suppose something like this. In that case, the dictionary would look something like this. D equals 7 would be at 1, 4 would be at 2, 2 at 3, and 3 at 0, 1, 2, 3, 4, 4. It would look something like this. This only stores the last location of its appearance in the array. Okay, but I'm actually gonna kind of ignore that for now. What I'm gonna do is I want to focus on this value, here. I'm gonna focus on this value here. Now, if we were at this value here, let's imagine how our dictionary would look. How would our dictionary look? Well, remember, we only store a value's latest index. So this would be 401. So this would be correct. Also, though, we're only storing things in front of us. So that means we wouldn't have this at the moment. We wouldn't have it at the moment. Okay? So we're only storing things in front of us. So what we'll be doing, though, is once we arrive here, we'll always try to go back and figure out how many of those can we include in our usage. So what I mean by that is this. So currently we are at 3. So currently we are at index 0, 1, 2, 3, 4. Index 4, value 3. So what we'll do is we will loop through our dictionary and look for elements that violate continuous. So remember what it means to violate continuous. It means that a violation occurs when the absolute difference is greater than 2. So let's just verify that really quickly. So remember, it says a subarray is called continuous if for each pair of indices, this part here, the absolute difference is less than or equal to 2. So what we're looking for, we're actually looking for violations. Once we find a violation, we need to remove that element from our dictionary. And then we need to adjust our index. Okay, so let me see. So, okay, let me write that down. Once we find a violation, we will remove that value and index. Okay, remove our value index. Okay, that's right. Okay. And let me see, and move forward the, what do we call this? We'll call this maybe the acceptable index. So let me go over what I mean by that. So suppose we're at 3 here, and we want to loop through all of the previous values that were acceptable. So before we get to 3, we would have to be at 2. Now, if we're at 2, remember, this dictionary will always store the current acceptable values and indices that are have a value of 2. So looking at this 4 here, the only value that has an acceptable value of so looking at this 2, the only value that would be acceptable is this 4, because 4 minus 2 is 2. 7 wouldn't be acceptable because the absolute difference is 5. It's too much. So at this state, if we're looking at 3, if we're looking at 3, the dictionary should only have these 2 values in it. So let's look at that. So D equals, so that would be what, 4, 2, and 2, comma, or 2, 3. 0, 0, 1, 2, 3. Yes, correct. And what we'll do is we'll look through our dictionary to see which one violates our continuity definition. So we'll do something like this. For key value in, well, dictionary, D, check if absolute difference of, we'll call this key and maybe current number is greater than 2. If it is, what do? Well, we need to actually remove it. We need to remove that key value. Because remember, we're looking for continuous, remember what they asked us for. They want continuous subarrays. They have to be continuous subarrays. So what I mean by that is, if it doesn't work, what I mean by that is something like this. Let me just change this. If it doesn't work, suppose we have something like, yeah, let's make this a call this a 0 here. I think they accept any numbers, right? Oh, say the smallest number can be is 1. Sorry, let me change the example. So suppose we have something like this. So let's keep it as a 1 and change this to a 4. Okay, here we go. So if I see this, so if I'm looping through my dictionary here and I see this 1, well, and the index of this 1 is at 0, 1, 2. That means no matter what, like suppose the next number is 5, or no matter what it is, 4 cannot look at this 1. It's not acceptable. So we're always trying to advance this index to whatever is the maximum. So let me change this now. So what if we have something like this? What if it is, okay, 2? So if we're looking at this, actually let me put a 1 here. So if we're comparing this 4 and this 1, this doesn't work. So we would advance our index, what I would call the global index. We would advance it here. But suppose we have this index here. Then we need to advance it here. So what I'm trying to say is that whenever we come upon index value that doesn't work, we need to advance it, because that means no longer can we look back over there. Can no longer ever look over here. As soon as we find something, we're always trying to find the maximum the maximum index that places us into a violation. So the maximum index that puts us into a violation where we're no longer continuous. Okay. So looking at this 4, the maximum index we can use is up to this 2. However, though, if we're looking at the 5, if we're here, the maximum index we can look at is the 4. So my point is, every time you come to your new value, you're always trying to look back, and you're saying, which one of you is the maximum I can use, the closest? Well, actually, I'm trying to go as far, but if something fails, I need to keep you within range of acceptability, within range of continuity. Okay? So let's go over this then. So what we're going to do is we're going to loop through all of our numbers. So loop through numbers. And what we'll do is we'll use the index and the value, or the number. And okay. And then what we'll do is we'll look behind us. So for key value we'll call this the dictionary. And what we'll do is we'll also have something called maybe this index. This is the, actually I'll call this left. The leftmost acceptable index. So left equals 0 now. And maybe I'll just call this right. This will be the right index. So currently they both start at 0. And every time we look behind us, we'll call this look, behind us, behind current number. We'll check if key and num, or let me see, check if absolute diff of key and num. If it's greater than 2, then we need to adjust our adjust left. And then we also need to remove that key and value from dictionary. Because we know once this happens, we know every other element behind us, in front of us, can no longer use that. Once it fails with us, so once it fails, for example, once it fails here, so 2 and 1 are acceptable, but 4 and 1 fail. And so that means 5 and 1 also fail. So we can't use it anymore. So once we suppose this is the 2 again, it doesn't matter, like all these 1s and 2s all work just fine, but it fails at 4, so it fails here. Just because 1, 1, 2, and 2 work with each other, but the 4 is blocking it. Remember, they want this to be contiguous. So that means there can be no gaps. So once it fails with 4, we can't use it. So it doesn't matter. So we need to remove it. So we remove it, and then we update our arrays. So my point to you is this. So what if we're here? Suppose this was a 3 here. So we know 3 works, that's 1. We know 2 works, we know 1 works, and 1 works. So in essence, so as we enter this, the right index would be what? 0, 1, 2, 3, 4, 5. So it would be 5. And the left index would be here, because remember 2 says 2 and 1 also work. So left would equal 0, 1, 2, 1, 2. So we need to put this into the contribution for our total. So what we'll do is we'll say, okay, right minus left plus 1. And that would be 5 minus 2 minus 2 plus 1, which would equal, what is that? 3 plus 1 is 4. So we would get four new elements because of this 3. So those four new elements would be 3. They'd be 2 and 3. They'd be 1, 2, and 3. And they'd be 1, 1, 2, and 3. That's what we're doing. So that's what we're keeping track of as we use this all along. And now if we were at the 2, we would have added, so in that case, left would still be 2, but right would be 4. And in that case, we would have added, let me see if we can cover this down here. In that case, we would have added 5 minus left, right would be 4. So 4 minus 2 is 2, 2 plus 1 is 3. We would have added 3. And those 3 would have been, well, let's take this off here. It would have been 2, 2 and 1, and 1, 1, 2. It wouldn't have been those. So that's why we leveraged the use of this dictionary to help us figure that out. Okay, Let's see if we can implement it now. So let's start off with our left pointer. So left pointer equals 0. What else do we need? We need our dictionary. Call this D. And I think that's, oh, we need our result. We need our result. That's also 0. And then we'll need our global index. Sorry, our global index is left. I think that's fine. Yes, okay, I think that's it. So let's move on. So for, we'll call this write and num in enumerate. Call it nums, is fine. And what we'll do is, well, let's do this something for now. Let's do this for key value in dict.items. And we want to check if there's a violation. Remember that? We want to check if there's a violation. There is a violation, what do we do? Well, let's check it first. So if absolute difference of key and num is greater than 2, what do we do? Well, we'll want to remove that element. So we'll say we'll do this there, d dot pop key. So we'll remove that element from the dictionary. What we'll also want to do is we want to update our left pointer because we can't use that value. So the left pointer will equal the maximum of the left pointer. And so suppose, like in this case, where are we at? So if we're at 4 here, and suppose the index we're looking at is this one. Suppose we're looking at 1. So this is at index 0, 1, 2, 0, 1, 2, 3, 3. We cannot use this index, so we'd want to check the one after it. That would be the acceptable index. So we couldn't use this one. So if this index fails, we need to set it to the max of it or the very next one. So let me write that down. So the max of left or the next index, which is this value plus 1. And so if once we get to that, we'll store that. So we'll say dict of num equals the right. So remember, this dict is storing the value, and then the index is where it's found. So when we loop this d.items, this key is the number and this value is the index where it's found. So once we do d.pop, we're popping the number from that dictionary. And a couple more things. Well, we need to return the result. Return result. But we also need to update the result. So the result would be, remember, as we did up there before, we did, what was it, right minus left plus 1. Now this is gonna fail, it's gonna bomb. And I purposely made a mistake because I want to point something out. So let's run it. There we go, perfect. So it says dictionary change size during iteration. Perfect. So let's figure out what that means. So here. So remember, we deleted or we removed that element from the dictionary. So in Python we can't do that. So we need to do a little bit of a modification here. We need to do something like t equals, or maybe, yeah, sure, t equals d.copy. And then we'll do something like t.items. And then let's run it. Oh, what did we mess up on? Hold up. Wait a minute. Something ain't right. Oh, yes, I know what it is. Silly rabbit. Okay. Anybody see where it's at? Remember, all along we're supposed to contribute it. We forgot to contribute it. We just said it. Okay, great. And now let's submit it. Okay, it looks pretty good. So I think this problem was tricky. I do think this type of approach is pretty valuable to know. And the approach I'm describing or talking about is where we store the last, what is the word? The last instance where, or the last location where a value is acceptable. So remember how we store the number and the last time we see it. So this is a technique or an approach that I've seen multiple times on Leetcode, and I think it's something worth exploring because most likely you will see it again. Maybe not too often, but you will see it again. I think I've seen it. This is probably for sure my second time, and I want to say probably my third time. So try to become familiar with certain techniques, and then as you practice more and more, it'll become easier to implement it and use it with your coding as well. Okay, if you found this in any way helpful or educational, please consider liking or subscribing. Have a wonderful day. Take care.